So, test number 1. What are we going to be doing, Gareth?
We're going to be trying to find out how much power each fridge consumes
Okay.
running at its maximum speed.
So, how do we measure consumption of the fridge?
Well, basically, it's two things. One is its power, its
Yeah.
watt draw, and the
Okay.
other one is its ampere hour draw.
Okay. So, whoa, hang on. Let's go step back. Wattage. When you're saying watt, what does the wattage mean?
Watts is power.
Okay.
So watts equals volts times amps.
Okay.
Yeah. So your volts, let's call it 12 volts times 10.
Yes.
Means it's 12 times 10 gives you your wattage.
Okay.
Yeah. So we're going to understand what is the power consumption of the fridges.
Okay.
And with that, we've got a monitor that will see those particular fields.
All right.
And then from that, it's actually what the consumption is.
Okay.
So
now let's take a step back. So we say wattage. Now you're saying consumption.
Yeah.
And that's amp hour. So explain to us in layman's terms on amp hour. Why would I look at something like amp hour?
basically, a battery is like a bucket full of water.
Okay.
Yeah. And each time you take a drop out,
Yes.
yeah, you're removing what that capacity
Okay.
is. So if it's a 10 litre bucket of water,
Yeah.
and 1 ampere hour is 1 litre.
Yes.
Yeah, if you've got a 10 ampere hour bucket, you can pull 10 litres out and it'll be empty.
And that's done.
And that's the consumption. So if it's consuming 1 litre an hour,
I
it'll
need
run
to
out
get
in 10 hours.
I need a bigger battery to
Yeah.
last all night.
Yeah. So, we all use
Okay.
ampere hour as our capacity on the batteries.
Right.
And we're now looking at these as to see what is it they're drawing.
Yes.
So when we look at going to buy a battery, there's our ampere hour for the battery. We say, our fridge will run that many hours.
Okay.
We gotta-
So, but by putting these now, so we're going to take a room temperature bottle of water and we're going to be sticking in here. The fridges are at room temperature and we're going to crank them up for 2 hours. So they should be drawing the absolute most or worst case scenario, because I doubt they're going to cycle within 2 hours. They're going to, you're setting these fridges at minus 22. It's a lot of power to get down to there. So we're going to get worst case scenario in this test, I suppose.
Yeah, I mean, this is the point. The fridges run flat out on their compressors. We're
Yeah.
setting the temperature at its lowest.
Yes.
So the whole idea is to run full power.
Okay.
How fast can this get down to the lowest
All right.
temperature? The other thing we're going to do as well is we've got to check. We've put an independent temperature gauge in there as well.
Yeah, so we're going to run, yeah, I mean, I know for a fact, running the various fridges that I own, running an external fridge monitor, these are the Engel fridge monitors, but you can use whatever, the difference between what it says here on the fridge and what it actually says on the fridge monitor that's inside is totally different. So this is where we're going to be measuring
and this is
the
what we're
actual
trying to
cooling
do.
from, right?
Are we comparing eggs with eggs,
Yes,
or
okay.
apples with apples? Is this coming down to minus 22? Is it minus
Yeah.
22? Is this one, whatever it is, to see that, to check that what these fridges are saying they're doing, they're actually doing or not. And if they aren't, then we're going to take them to that point to then compare that point against each other.
Okay, so it gives us a level playing field for all of them, starting them off. We can measure the ambient temperature from this because it's got the outside temperature of the fridges and then the inside temperature of the fridges.
Yeah.
Right, and then a step further, we, instead of putting the bottles of water inside the fridge up against the elements, one of our tests have just finished. We'll be back in a second. We need to get some data. All right, sorry about that. We had to get some data. We're back again. I think we need to get into it. We're going to set it up right now. And, well, first of all, explain how we're going to set it, how we're going to measure this now.
Well, we're going to measure it with a battery monitor.
Okay.
And the battery monitor has a shunt which measures the current across the shunt.
Okay.
And that battery monitor will give us our wattage,
Yes.
our voltage,
Yes.
and our current ampere hour draw.
Okay.
So it gives a current draw as well. So it actually does the conversion and calculates the ampere hour.
Okay,
for
so
us.
we're going to go fridge straight through to fridge runs in through to the
Yes, we've set up
shunt.
a test rig basically. So we've set up a test rig with the battery, the shunt, and 2 terminals for us to connect onto. So it's all identical for each fridge.
and it's
Running
identical on
12.
the batteries thanks to Batmobile. So done deal.
We're using the same ampere hour batteries, so that the whole draw and the current sag on the batteries should be approximately the same. And we can just see how these fridges are actually operating. So they should give us all the parameters.
So we're going to start off data collection, we're going to start off at the start, obviously. Ambient temperature, bottle temperature, fridge inside temperature, which is all room temperature, which we can control. We're then going to move, we're going to measure at 1 hour, correct? 1 hour?
No, we're starting our first startup.
Oh, yes.
So we do our first startup
So
power.
what power draw from stationary, from resting position, starting up, it's going to then kick in that in the compressor.
Yeah.
So that's probably going to be your highest wattage draw at that point.
Well, we're going to look at that and see what it goes, because we're also going to do a 10-minute test as well.
Okay.
And have not a test, but have a look at 10 minutes and see what it's drawing then when it's all settled down and the compressors have ramped up. A lot of these fridges have soft starts in them, so it slowly ramps up the speed, gets all the stuff moving around.
Okay, I suppose this is also going to be able to give us an idea of the software in these, because some of these fridges do run the same compressor. However, the way that the software is put together is very different. So some of them could be aggressive, some of them could be slow.
You can see them. I mean, the SnoMaster has a digital display.
Yeah.
This is a very basic display, and the Engel, it's totally analog, you know. So it'd be quite interesting to see how they operate.
Good.
And see how they run the compressor.
So we'll run start, the 1 hour test, the 2 hour test, and the 2 hour test will then give us the amp hour over 2 hours, the wattage, the high points on the wattage, and then obviously the bottle temperature, because we're going to be testing the water. And the reason why we've gone to water, we've done this test a couple of times on soda, and the inconsistencies are insane. So we've gone to water bottles instead of using anything with gas, because it was just, there's too many variables. So we'll stick to water, and it should be consistent enough for you guys not to give us too many issues or too many questions. All the scientists out there, please hang 10. All right.
But we're trying to keep everything the same. That's the point, you know. We don't want anything to be too many. Water is where it's at. You know, we know what water does. Water is pretty simple. When you start adding fizz and bubbles and sugars, and
freezing points change and all kinds of things like that. So water should freeze at 0.
Should do.
Should.
Yeah.
So, all right, so we're going to get into it. I will be recording the entire process, but we're not going to air it in the show because it will just take too long, right? But at the points when Gareth and I talk about the points, what we reached, I will cut to that. But for the skeptics out there, there is no editing whatsoever. We will be recording each 2 hour stint, so it's there for you to view if you want to. Right.
Perfect.
Good. Let's get into it.